So this is going to be 20C and D, and it's on measuring the spread of data. And the ways of measuring the spread of data that we're going to look at in these sections is the range in the IQR, which stands for the interquartile range. And then later we'll talk about the standard deviation. So let's talk about, range. Oh, I gotta insert a page here before it'll work. The range is simply the maximum data value minus the minimum. And then in order to understand the IQR, we have to know about the quartiles first. So there are quartiles, which you find by dividing the data into fourths. But before you do the quartiles, you have to order the data first. So you order the data, and then the lower quartile, or it's also called quartile 1, is going to be like a quarter of the way. So it's the same as the 25th percentile. In other words, 25% of the data is at or below. Did we already do cumulative frequency charts? I don't think we have. Anyway, so 25% of the data is at or below the lower quartile. And then there's the median, because that's at the 50% mark. That's also quartile 2, but we don't usually write quartile 2. And that's the 50th percentile. Obviously, we already knew that because that's the middle. And then the upper quartile, or quartile 3. Well, I could put or quartile 2. We don't call it that, but that's essentially what it is. And then the upper quartile, it would be the 75th percentile. And then quartile 4 would be the max. But again, we don't talk about it that way. And then, by the way, if you write the min here, whatever the minimum value is, you find your quartile 1, quartile 2, which is the median, and then quartile 3, and then the max. These together are called the 5-number summary. And then the IQR, which is the interquartile range. Inter means between. That's the upper quartile minus the lower quartile, or quartile 3 minus quartile 1. Is the range affected by outliers? Yes, because the outliers are going to be the maxes and the mins, aren't they? So if you have really big values on the ends, it's going to change the range. Is the IQR affected by outliers? And the answer is no, because the outliers are way out here. They're not going to affect these values here in the middle when you list them. So the IQR is not affected by outliers. So it's a nice measure of the spread of the data. So the larger the IQR, the more spread there is, like if you're comparing two sets of data. If one of them has a larger IQR, it's going to be spread out more, especially over those middle values. So let's go ahead and, I'm just checking my notes, make sure I'm not missing anything. Let's go ahead and do an example. So I just made up some numbers here, and we're going to find the 5-number summary, the range, and the IQR, and then we're going to check it on our calculator. So first we have to order the data. That's very important. If you don't, you're going to be in trouble, and you'll soon find that out, as I did on a previous example a while back. So we've got 5, another 5, a 6, let's see, 1, 2, 3 6s. I've got a 7. I've got 4 8s, 1, 2, 3, 4, and then a 9. And I always double check and make sure I at least have the correct number of data. So I've got 11 here. So down here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So what I have here is I have an odd number of data, an odd number. Whenever you have an odd number, Your median's going to be smack dab in the middle, and it's going to be a value. Oh, by the way, let's practice that formula again. 11, even though you really don't need to on a data set this small. 11 plus 1 over 2, 12 over 2, that's 6, so it's the sixth number. Right here is your median. So now, pay close attention here. When you're finding your lower quartile and your upper quartile, you're going to cover, you can't see my hand, but what I'm doing is I'm covering this 7 up with my hand. So cover up the 7 with your finger or your hand, and then the data on the left, you're going to find the median of that. So that's the 6 here is going to be the middle of this lower half. I can draw a thing like that. So that's quartile 1. And then I'm covering up the 7 again with my hand. So on the right, I just have these 5 values, and so I'm going to find the middle of that one, which is 8. So that's my quartile 3. And then, of course, so let's do the 5-number summary. The min, the lower quartile, the median, the upper quartile, and the max. Min is 5, quartile 1, median, upper quartile, and the max. So there's my 5-number summary. Then we want to find the range, so that's simply going to be the max minus the min, 9 minus 5, which is 4. And then the IQR is the upper quartile minus the lower, so 8 minus 6, which is 2. And now to check this on the calculator, what we're going to do, I think I'll go to y equals and clear those off, just because. You're going to go to Stat, which I just pressed, and we want to edit. We want to enter our list, so you just hit Enter. And then, actually, there's just one list in this case. This is one variable statistics is what this is. So you could either list it the original list or the second one. I'm going to do the original one, just in case. What if I made a mistake typing these, or listing them? You never know. If I did, then this would catch it for me. 8, 8. Follow along with me, too, on your calculators. If you have a Casio, hopefully you know how to do this on yours, because I don't. Great. Now they're in, so I'm going to go to a blank screen, and then we're going to do calculations. So we're going to go to Stat, Calculate, and these are all just one variable, so one variable stats. And I'm in L1. It's going to default to L1, but if you want, you can do second L1. Hit Enter. And the X bar is actually the mean. Okay, whoops, I went a little too far. Okay, here we are. Here's our 5-number summary coming up. So N is the number of values. So the min is 5. Yeah, we knew that. Quartile 1 is 6, just like we did. 7 for the median. 8's the quartile upper, and then the max of 9. It doesn't tell you the range in the inner quartile range. You have to figure that out on your own. Okay, I need to look at my notes and see. Okay, that was example 7. In a bit, we'll do one with an even number of data values, so you can see how you find the 5 numbers with that. But for right now, we actually, I'm trying to see where I left off here. That's weird. Oh yeah, okay, I see where we're at. You know what, we're actually on 20D right now. So that was 20C. We already did 20C. So this is 20D. This is on box plots. And what we have is some examples of some data with different distributions. The pink here, you can look at that. What kind of distribution is this? Well, it's approximately symmetrical. I can even draw that in there. And notice the box plot is also very symmetrical. So down here we have the box plots. We're going to make some of these, and you maybe have made them in the past. But you can see that the min is here, the max is here. This is the median. This is the upper quartile. This is the lower quartile. So the min and the max are sitting right under there. This is telling us the median is here at 15. And notice that this describes the inner quartile range, right, from here to here. The box is also symmetrical. Okay, this one is skewed positively. Again, you can see the min and the max really obviously. Notice, though, with the box, when it's skewed positively, you can think of the median being right here in the middle. And think about since it's positively skewed, it's like this box is stretched out to the right. So that's going to happen when you have it skewed to the right or positively skewed. The median will actually be kind of on the left hand, to the left of this little box. And the box itself is to the left of this entire distribution. And here we have I'm trying to remember what these are called. I know it too, but I'm not going to be able to think of it right off the top of my head. There's a name for these. A lot of times we use X's. When I think of it, I'll tell you. Anyway, this is skewed to the left, and again, you can see that since it's getting skewed to the left, it's being pulled to the left. So like the little box here is getting pulled to the left is the way I think of it, making the median closer to the right. And then you can see too that the min is stretching out to the right, or to the left, I mean. Oh my gosh, did I say the wrong thing? Anyway, I drew the arrows right. So this is if it's skewed left. Yeah, the median is to the right, but these boxes are stretched out to the left. So now we get to do example 9, which is this one. Well, it's 9 in the book. I call that example 2 here. So we have some data. We are going to find the 5-number summary again, but this time we're going to draw a box plot also. And then I'm going to show you how to find that on the calculator. And then when we're done, we have a question to answer. So first step, order them. Okay, so I've got 2, 2, 2. I've got 4 2s. I've got 1, 2, 3, 2 3s. I've got 1 4. 1, 2, 4 5s. 1, 2, 3 6s. And 8, 9. And I'm going to check and make sure I got all the data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's 16 of these. 14, 15, 16. Okay. So here's an example where we have an even number of data. So the median is going to be between the 8th and the 9th one. 4, 5, 6, 7. Here's the 8th. So right in here is your median. So between 5 and 5, that's just 5. Now when you find the lower quartile, you're just going to look at the median of everything to the left of this middle bar here. So you're not covering up a number this time. So let's see, I've got 8 data values again, so the median is going to be between these two, so 2.5. So that's actually the lower quartile. And then we have to go 1, 2, 3, 4. So it's between these two will be the upper quartile. That's the U. Now we can write our 5-number summary pretty quickly. Please label your 5-number summary. It doesn't take that long to do. 2, 2.5, 5, 6, and 9. Just for fun, let's do the IQR. 6 minus 2.5, so that's 3.5. Now let's make a box plot. It's really important when you're making box plots to start with a number line. It's important enough that I'm going to write it down. You have to start with a number line. If you don't, your box plot's not going to be drawn to scale. Must start with a number line. So we're going from 2 to 9. Make your number line as beautifully as you can. In other words, make these evenly spaced. That's all I need. So now we get to put the box plot on there. I usually start with the median at 5, so I'm going to put a bar above, like a vertical bar there. And then lower quartile is 2.5. So right here I'm going to have another vertical bar. These are the same, like translated left and right. They're parallel and they're perfectly translated. Upper quartile 6. Okay, I can see which way is this skewed. Okay, it's skewed left, isn't it? Because here's your median and this box got stretched out to the left. At least as far as the box part's skewed to the left. Now the min is here. So for the min, you put a little tiny, this is the whisker. These are called box and whisker plots, by the way, also. This is the little whisker, the min, it's a little one. And then the max is at 9. So like on these outer ones, it's more skewed to the right, isn't it? There's your box plot. Now let's do it on the calculator. So we'll go to Stat, Enter. We'll go back, we're done with that other data. Go up, clear it, come down. I don't remember if I mentioned clearing lists, but you go up to the top. Whoops, that's not what I want. You go, so say it was down here, you're going to arrow up, press clear, and arrow down. That's how one way to clear lists. So now I have to put all the data in. I am going to go back and use the original data in case I made a mistake. And this is going to take me a sec. And hopefully the cursor seems to be working well today. If I did make a mistake entering this, when I do the if my 5-number summary is different than what I got by hand, I'll notice the mistake. So there are 16 data values, so I got them all. Second quit, clear out the old stuff. Let's calculate our 5-number summary again. Stat, calc, enter. I can just hit enter because it defaults to L1. And this is going to tell me confirm whether or not everything is going well. 2, 2.5, 5, 6, and 9. Great. Now we get to make the box plot. So anytime you're doing that, it's going to be a stat plot. So it's up here. So it's going to be second y equals. And we need to turn on our plot. So we're going to hit enter. Hit enter to turn it on. And then we're going to arrow down. And the box plot we want is this one here because you can see the median in there. I'm not even sure what that, I don't know what that one is, to be honest. I've never used it. Hit enter. And then you can press. Before we press graph, we need to go to set our window. The y's aren't going to matter as long as they don't go from 0 to 0 or -10 to -10. As long as there's some kind of a gap here. The x's, I'm going to go from 0 to 10. Now I can press, there it is. Beautiful little graph, so quick, practically instantly. And I'm just looking at it and it looks good. Notice you can trace and then arrow to the right and it gives you, look at that, it gives you the labels down here, tells you what you're doing. So it's pretty cool. You can also, in the homework, they're going to have one where they give you 2 data sets. If you have 2 sets of data, you'll have one in L1 and one in L2. And then when you set your stat plots, you'll have one plot, like you could do L1 in plot 1, and then you could come down here and in plot 2 you could do L2, and it'll plot both of them on the same screen. And then finally we need to check the percentage of data values less than 3. Now if you look here at your box plot, you're not going to be able to tell how many data values are between, in this area of the box. So you have to go to your list. So less than 3, that means it's just these right here. And we had 16, so 4 out of 16 is 25%. Once that's all listed, it's pretty handy, isn't it? Now let's talk about outliers. Well, we already talked about outliers some, but there's this cool way. There's actually a formula that will tell you whether a data value is an outlier or not. And here are the formulas. So as you know, you can have outliers on either end. So to get the upper boundary, you're going to find your upper quartile, and then you're going to add the product of 1.5 and the IQR. So in other words, with your, like on your box plot, that's pretty bad. Let's just say I'm going to make up one. Here, it will go out like that. Oh, whoops, it's supposed to be a vertical bar. So essentially what it's saying is, here's your upper quartile. If you take the length of this box, that's your IQR, and multiply it by 1.5, so that's in other words going to be 1 and then a half. Right to here is going to be your upper boundary. Anything past that is an outlier. And likewise on the other end. So you can clearly see with this box plot I would have an outlier. This would be an outlier. And over here, this is clearly not an outlier. I looked in the formula sheet for IB. These formulas are not on the IB formula sheet. So you're either going to have to memorize them, or maybe they're not going to ask you this on the exam. That part I do not know. Oh, by the way, if you are making a box plot, and there is an outlier you've identified, then the way you're going to fix this You're actually going to graph your box plot a little bit differently. So pretend I had my data values, and see before I had like one way out here. You're going to write that with an asterisk. And then you're going to come back in here. And this data value is not an outlier. So that's going to be your max. Making sure I did that right. Each something I see, I can't read my number half the time. Oh yeah, each whisker extends to the last value that is not an outlier. So this is my whisker, this is at my upper bound here, and then my outlier would be marked with an asterisk. And that's what our book is recommending that we do. I'll admit that's new to me, I have not seen that before, but we'll do what they do. So here's an example to practice all this stuff. This will be our last example. Okay, we have all these data. We have to test for outliers and make a box plot. So because I'm going to be making a box plot, I'm going to have to order these values. I can also see I'm going to run out of time here real quick. Like lunch is coming up, so I'm just going to go ahead and write. I've pre-listed these to save time. I'm going to just do that right now. I'm going to have to write smaller. Okay. And I counted these ahead of time. There are 20 of them. I usually put it in a little circle. So we have an even number of data. We know our median is going to be between the 10th and 11th. 8, 9, 10. So right here is our median at 8. So let's do our 5-number summary over here. Min, lower quartile, median, upper, quartile, max. Median is 8, min is 1, max is 16. Okay, I have an even number, so I'm going to do half of these. There's 10 of these, so 1, 2, 3, 4, 5. So here's going to be my lower quartile. 1, 2, 3, 4, 5. So 10 is my upper quartile. And I'm just going to double check my math here with my notes, make sure I'm not making any mistakes since I'm going faster. IQR is upper quartile minus lower, so that's going to be 3.5. The range, just for fun, 16 minus 1 is 15. I can see it's going to get loud here. Now, it's lunch right now, so we're good. I'll just wrap this up. The not the box plot. We are going to check for outliers, so we're going to use the two formulas. We need to find our upper bound. I'm going to abbreviate that upper bound. And if you remember, that's going to be the upper quartile plus 1.5 times the IQR. So my upper quartile is 10 plus 1.5 times 3.5. And I've worked that out ahead of time. That is 15.25. The lower bound is and I like to think about this, so lower quartile minus 1.5 times the IQR. If you just think about that box extending 1.5 times on either side, it helps you remember this formula. Lower quartile is 6.5 minus 1.5 times 3.5. And that ends up being 1.25. Can you shut the door? And then so we can now look at our list here and see if we have any outliers. And yeah, so up on the upper 15.25. So this 16 here is going to be an outlier. And then on the other end, 1.25 is the only outlier we have on the other side. So now sometimes you will get a couple of outliers. You can have more than one outlier on either end, just so you know. But in this case, we just have one on each side. And now finally, we're going to make a box plot. So I'll just do that right here. I'll have to make it kind of small. And again, you have to start with a number line. We're going from 1 to 16. So I'm going to count by twos and kind of small. 2, 4, 6, 8, 10, 12, 14, 16, 18. That's good enough. And we've got a min at, okay, so we're going to start with our median at 8, which is right there. We've got a lower quartile at 6.5 now. That's kind of hard to tell because I've got such a small scale here. And then we've got an upper quartile at 10. So kind of a little box. And then the min, oh, I need to put 1 on here. 0, okay, here's a min, the small whisker. Oh, hold up. That's not a whisker, is it? That is an asterisk because it's an outlier. So we need to make an adjustment. So at 1, we have an asterisk. And then the next data value up from that is a 3, so our whisker is actually at 3. That's how we're going to draw that. And then on the upper end, I know my max is a whisker because 16 we decided already was an outlier, so I need an asterisk there. It's an outlier. And then 14 is the next one below that, so that's actually going to be my upper whisker. That's pretty symmetrical looking distribution, isn't it? With a couple outliers on the ends. And now it's time for lunch.